Hi, I'm Brian Cullen with Maximator-Test. Today we're going to demonstrate the capabilities of our high-pressure Impluse test stand. The test stand was designed to do accelerated pressure fatigue testing on a variety of components for PPAP, material validation, or product validation. Some of the products we test include high-pressure diesel fuel injection system components, such as common rails, injector bodies, pump housings, things like that. But we also test a variety of other components, high-pressure sensors, pressure gauges, items for the chemical and oil and gas industries, water jet cutting systems, components like that. But before we get to the test, let me show you some of the capabilities of the rig and some of the features of the test stand. This is where the rig gets its power. Here we have two 88 horsepower hydraulic motors. Along with it is a cooling water system, keeps the oil at the right temperature, as well as cooling other key parts of the rig. Let me show you the test chamber as well. This is the main test chamber. Here in the lower section is the high pressure intensifier. This is the heart of the rig. This is where the pressure waves are generated. Pressure waves are generated and they move up into the manifold here in the upper section where we put the test samples. Let me show you a little bit about the test chamber itself. The size of the test chamber allows us to test large or oversized components, while they have plenty of room for support fixturing for heavy test samples. Here we have a multi-port manifold, gives us a lot of versatility for testing multiple customer samples at the same time. On the test manifold you can see our calibrated 5,000 bar pressure transducer. This is how we measure the pressure to the test samples. In addition, Maximator installs a backup transducer. With this, we measure the pressure differential between these two transducers. If that differential pressure changes during the test, it'll shut down the rig. It'll indicate that we've got a failure of a transducer and shut down the machine. We're ready to go. Let's close up the doors and start up the test. Alright, the test parameters for our demonstration today will be a test from 50 bar to 4,500 bar. It's about 725 psi to about 65,000 psi. We'll do that at a frequency of 15 hertz or 15 cycles per second. This is the kind of typical test we run for a customer that's trying to validate a new design or even a material change on an existing design. We can run a 5 million cycle test in roughly 4 days with this. Here on the setup screen, you can see that Brian has already input the test parameters, the high and low pressure set points, the frequency, the number of cycles, in this case 10 million cycles, and here we enter the sample ID numbers. We can go up to 24 samples on this test. From here, Brian will go into the test run screen. On this screen, you can see we have basic sine wave shape. We have the controls we use to optimize the performance of the rig. Here you can see our test pressures. Got a max pressure of 4,500 bar, minimum of 50 bar, and a frequency of 15 hertz. The total number of cycles to run, and the counter. It'll count down from that's a 185-hour test, and our sample input. You can see that just within a few cycles the rig has reached the set point pressures that we programmed in. You can see the cycle count is ticking away, adding up cycles. That's it. The test is up and running. And at 15 hertz, barring any failures, 10 million cycle test will be complete in about 187 hours. This rig can run unmanned 24/7 and it'll only stop in the event of a failure. With this machine, we can quickly and efficiently test your parts to your specifications, give you the data you need to make important design or warranty decisions. We also conduct leak pressure testing, burst pressure testing, as well as auto foutage up to 15,000 bar. To find out more, you can visit our webpage at www.maximator-test.com or give us a call at 847-855-2700. Thanks.